Okay, PreCalculus, this is 7-3, video number 2, backside of the notes, 7-3. I'm on page 14 of the notes now. We just started it a little bit in the end of the previous video. We're talking about amplitude and period and how to change it. So it normally, we just did it on the previous page, our graphs will go up as high as 1, as low as -1. To change that amplitude, you just put a different multiplier in front of cosine or sine. Okay, let me change this focus. Looks like it's a little bit out of whack. A little better. All right, if you're going to graph y equals 2 sine x, the amplitude is always a positive number, so they call it absolute value of 2. So if it is negative in front, just call it by the number without the negative sign. So it's always the absolute value of that number. So the amplitude is 2. It's the number out in front. Like down here, this amplitude is considered to be 3. I'll even write it in right now, not -3, even though negative means it's going to flip it upside down. We'll get to that. You're always going to break the period up into, this is where I cringe a little bit. I'm not crazy about the notes. It's going to break it up into B parts. So that letter B there. But that just means you're taking 2 pi and you're going to divide it by the B value. All right, you're going to divide it by the B value. But then you have to figure out, like, what are the points. It's kind of a tricky thing to learn. That's probably going to be the more important part on page 2 here. The range for the sine wave is usually as low as -1, as high as +1. Because of the amplitude change, the new range, it'll go as high or as low as 2 and -2. It'll go as high above 2, above the x-axis, to below the x-axis. So it's going to go from -2 as tall as 2 for this particular graph. Oh, that's actually not what they wanted here. They wanted me to do it this way, -2 and 2. All right, I'm sorry, I was copycatting what was here. It does mean this means this, but this is what they're talking about for the new range. You got to show it as that ordered pair, but included from -2 to +2. The sine graph would stay the same, so our key points don't change. It's going to stay at 0. Evenly space these out, pi over 2, and then it would be pi, and then it would be 3 pi over 2. This one's 0. And then it would be back to the beginning at 2 pi, and then it would repeat itself. The only difference here is that it's going to reach a different high and a different low as it does the loops back up and down. So sine graphs start at 0, 0. Cosine graphs start at 0, 1. In this case, it goes 0, 0, and then at pi over 2, the top of the graph, we're going to be at 2. Then it back down to 0. Then as low, it's going to bottom out at -2, and then back to 0. And so that's what a change in amplitude does. Of course, it would keep going, and it would keep going. We don't show more of it. We show one period length. We show one period length. Okay? The period is 2 pi. Intervals is to figure out how long it is in between these points. So the intervals is the period divided by 4. All right, so if I did 2 pi and I divided by 4, I get pi over 2. So the length in between is pi over 2 and pi over 2 and pi over 2, pi over 2. That's going to be important at the bottom of the page. All right, let's do another one where we change the amplitude. If you throw 1/2 in front, so if this is 1 and this is -1, it's only going to reach a half and a half. And so it's going to really lower the loops. And it's a cosine graph, so it's going to change some things. The period doesn't change. The period is still 2 pi. And so our key points are what we're used to. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right? The only difference is that instead of starting at 0, 1 for cosine, now we're going to start at 0 and 1/2. That's the top of the curves. Then it's going to hit 0. Then it's going to bottom out at -1/2. So it's -1/2 right here. Then back to 0, and then as tall as 1/2. And so our cycle looks like this. All right, the amplitude here is 1/2, or you can call it 0.5. And then if they throw a negative in front, so cosine usually starts up here and it looks like this, right? That's what cosine, we're going to flip it upside down. It's going to start down here. It's going to be upside down from what we normally have because of that negative sign in front. And the amplitude changes. It's going to go up 3 and down 3 when it reaches its max and when it reaches its minimum. So the period doesn't change. The period is still 2 pi. All right, we're going to change the period down below, and that's where it gets a little tricky. It's still going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so it's going to start at its maximum usually, but now it's going to start at the minimum because of the negative. So we'll go down 1, 2, 3. It's going to start all the way down at -3. It's going to reach a height of +3. It's going to be, this is cosine. It's going to be flipped upside down though. My dotted line is what it's going to look like. So we're going to start at the lowest point of the amplitude. So it's going to be at -3. Then it hits 0. Then at pi, it's going to hit +3. Then at 3 pi over 2, we're back to the middle at 0. And then at 2 pi, we're here. And that is what it looks like. All right, as soon as we pass this point, the period repeats itself. The cycle looks the same. The curve looks the same. And the period repeats. The tricky part, all right, that's the last part. Be careful. In numbers 4 and 5, the b value is not equal to 1. In other words, it's not a 1 in front of x. This will end up changing the period. All right, that's going to end up changing the period. To determine the new period length, you plug the b value into this expression. It just basically, you take 2 pi, and you divide it by whatever that multiplier is with x, and it'll change the period length. If they draw it like this, I wish they started with this one, but they started with this one. They divided x by 2. Think of it as 1/2 x. All right, think of it as 1/2 x. And so b equals 1/2. To find the period length, you take 2 pi and you divide that by 1/2. And so what happens is you get 2 pi multiplied by the reciprocal, which is 2 over 1. And I get 4 pi is the period. Now that's important to start. What is equally important, and the part that kids have to practice when they learn this for the first time, is what are the intervals? How long is it in between these points? Now this one's going to be an easy one. We always want 1, 2, 3, 4 spaces. All right. Oh, I'm sorry, that wasn't on the screen. Let me do that again. We always want 1, 2, 3, 4 spaces going across. It's 5 points when you count the beginning and the ending. 1, 2, 3, 4, 5. But spaces is 1, 2, 3, 4 spaces. The intervals is how long those spaces are at. So the intervals are always found by taking the period divided by 4. Well, that's easy. Each one's going to be a length of pi. It's going to start at 0. It's going to end at 4 pi, and I need all those spaces in between. Each one is a length of pi. So this will be 1 pi and 2 pi, and I didn't space it out real well, and 3 pi. Let me scoot this over a little bit, and 4 pi. Sorry about that. You want the pretty even looking spaces in between. Did not do a good job of that. In fact, well, we're just going to roll with it. Okay? It's going to make my graph look a little goofy. But the amplitude is 1. So it's only going to reach a height of 1 and -1. It's going to follow sine. It's going to start here, and it goes up. So it goes here to here at 1 pi, here at 2 pi, here at 3 pi, and back at 4 pi. And I really wish I didn't. That doesn't look that bad. So you ignore my scratching out of stuff. The intervals are a length of 1 pi in between all those key points. 1 pi is in between all those key points. All right, I'll be a little more careful on this one. Cosine is 3 pi. This one's a trickier one. This one's definitely a tougher problem. cosine of 3 pi. Now the amplitude is 1. So it's going to reach a height of 1, -1, and because it's cosine, it's actually going to start here. It's going to start here. But finding all these points in between starts by finding the period length. The period length is 2 pi divided by whatever the b value. Now the b value here, I wrote b. The b value here is the number 3. And so the period length is just 2 pi over 3. So it's going to start here at 0, and it's going to end at 2 pi over 3. 2 pi over 3 is where it ends. Now the tricky part is, what are the intervals? Intervals. You got to take 2 pi over 3, and you got to divide that by 4. Divide that by 4. Well, when you divide by 4, what you do is multiply the reciprocal, 1/4. Right? Like if I made a fraction, you multiply the reciprocal, multiply by 1/4. So it'll be 2 pi over 12, which is pi over 6. That's the intervals. The intervals are pi over 6. So that's how long they are in between. So let's make some spaces in between. 1 here and here. We'll say it's here and here and here. So it's going to start at 0. It's going to go pi over 6. Now I got to do a little math in my head here. So the next one would be another pi over 6. So think of it as 2 pi over 6, but that reduces. That gives me pi over 3. And this is where it gets a little tricky. Go another pi over 6. So now it's 3 pi over 6. Well, that reduces, and that's pi over 2. Go another pi over 6. Well, now that's 4 pi over 6. And that reduces to 2 pi over 3, and that's the ending. All right, that's where it stops. Now, a cosine graph normally looks like this. We're going to copy that. We're going to still use that. At 0, we're at 1. Now it's at pi over 6. We're at 0. At pi over 3, we're down to -1. I got my numbers in the way because I wanted to write big enough to see on screen, but that's pi over 3, -1. At pi over 2, we're back to 0. And then at 2 pi over 3, we're back up here at 1, and this graph looks like this. And that's what the cosine graph is going to look like. All right, and it's going to take practice in order to learn how to break that up. This is always kind of a tricky part for kids when they learn this for the first time. So I understand if there's some confusion. It will take some practice in order to get there. But that is what the sine and cosine graphs look like. If you have any questions, let me know.